Hi, this is Maggie. In this video we're going to talk about writing to and reading from text files. There are two different kinds of files, text files and binary files. Text files are files that contain only text, and so they can be read with any program that can open a text file, such as a text editor or word processor. Binary files are files that are stored in a format other than text, so they need to be opened by a program that can interpret the binary information according to whatever format it's stored in. We're going to focus here on text files. This program obtains names and minutes from the user and writes them to a text file, one name to a line, followed by a minutes value on the next line, until the user is finished entering data. We will look at the parts of this program that relate to the file processing. First, we need to import the I/O library. Now we need a file reference variable. You can think of the file reference variable as pointing to a location in the file. We give that reference variable a value by opening a file. Here it is on the left side of an assignment statement, and on the right we have the open command. I pass two arguments to the open command, the name of the file and the mode. Because we are writing to the file, the mode is W. The default mode is R, read. This command will open a file in the same directory as the program for writing. If that file already exists, opening it for writing erases it and starts writing at the top. So after the open statement, we're ready to write to an empty file, and the file reference variable points to the top of the file. Now, in the loop, after we've obtained a name from the user, we write it to the file using the file reference variable .write. We must write a string to the file. Our name is a string, so we can write that to the file. Notice that we are appending a new line character /n to the name. This will bring us down to the next line, so the next thing we write will be on the line below the name. We then write the number of minutes, but again, because we can only write strings to a file, we must cast that to a string, and then again we append a new line character so that the file pointer moves down to the next line. When we are finished obtaining data from the user, after the loop, we send the close message to the file reference variable. This is important. If we don't close the file, the data might not get written to the actual file on disk. A file is an abstract concept. It exists in memory as a stream of data until it must be written to disk or until we tell the file reference variable to write it to disk. Now let's run this program and enter a couple of names and minutes. And then we'll open up the file and look at what the program wrote. Okay, so I've entered my names and minutes. Now I can open a text file and look at it from within idle. When I do this, notice there is a pull down which allows me to choose the type of file to open. I have to choose text files or all files if I want to see the text files. And there's my file readers.txt, and if I open it, you can see the data I entered, name on one line, minutes on the next. Now we'll look at reading from a text file. This program reads from a text file. When we're reading from a text file, we need to know something about the format of the file. That's an assumption we'll have to make. We might not be able to assume that the file exists or that the file contains data, but for our program to function and process the file, we need to make assumptions about how the file will be structured, or we can't process the data that's in it. We assume that this file is structured as name on one line, minutes on the next, so string on one line, integer on the next line, and that if there's a name, there's also a minutes value. We do need to know what we may assume and what we may not assume when processing a file, just as for any program. This program does not do error checking, but we'll talk a little bit about that after we go over the basics of reading from a file. There are a few things you need to be aware of. So first, just as with writing to a file, we need to import the I/O library and annotate a file reference variable, and we open the file. I'm explicitly passing in R as the second argument for read mode for clarity, but that isn't strictly necessary. Now, what I have is a sentinel controlled loop. I'm looping until the line that I read from the file is the end of file marker. That's an invisible marker that we can test for. So I need to read the first line from the file. That will be a name unless the file is empty. If the file is empty, it will be the end of file marker. The way to write an algorithm like this is to look at all the different potential configurations of the file and make sure your algorithm works correctly for every possible configuration. After I've read that first line in, either a name or the end of file marker, I start my loop, while name does not equal ... That empty string is the end of file marker. Now, I'm in the loop, meaning I got a name. Otherwise, I'm out of the loop, meaning I'm done reading from the file. If I'm in the loop, I have a name, the first thing I do is strip white space off of it. That's because the entire line was read in, and the line ends with a new line character. That's not part of my data, so I strip it off and assign the result back into the original variable name. Then I read the next line from the file, which is minutes, and then I cast that to an integer. I don't need to strip that one because casting to an integer will strip it. I then print what I read, and then I have to read the name value from the file again. This will either be a name or the end of file marker, and we jump back to the loop entry condition. If it's a name, we'll go back in and do it all again, and if it's the end of file marker, the loop will end. Once again, once we're done reading from the file, we close it. If we execute this program, it opens the file we wrote before, reads from it, displays what it's read, and ends. Now, if we want to minimize the amount of time we're interacting with the hard drive and read the file in quickly, we can use read lines. I'll demonstrate this in the console. I open the file in read mode. And then I'll assign into a list variable f.readlines, plural. And if I look at the data in my list variable, I can see a list of the lines in the file. I can now process the data in a loop, but I'm looping over an internal data structure, a list, rather than accessing the file on the hard drive. Now, when we wrote our file and read from it, it was in the same directory as our program. That isn't going to be practical on a large development project. You'll want to have folders for your files, images, sounds, etc. We can specify a path to the file from the program. So if you look here at a folder with Python programs in it and a folder with my text file in it, I have a folder at the same level as the program. If I want to access a file that's within the folder, then I use the folder name first / file name. I'll demonstrate opening this file and reading it from the console. So open, and then instead of just a file name, I specify the path, which begins at the same level as the program. That's the folder name. Then the file name. If we need to go up a directory, for example, if code were in a folder, and that folder was at the same level as the text file folder, so we would need to go up and then down, I'd use .. to go up a directory. Finally, we can check that a file exists by importing OS path, and before we attempt opening a file, writing if os.path.isFile and passing in our file name or file path. Quite often you will see Python programmers using exceptions, and when you are a professional programmer, you should follow the practices of the group you're programming with. We have a lot to cover, and we will focus on logic rather than exceptions, because logic is more generally useful both in Python and in other languages. This is something that you will definitely want to practice yourself, as it can be tricky both getting the order of reading correct and processing what you've read so that you have what you want. Writing to a file also has its pitfalls. Write some programs that write records of data to files, more than a list. Write several related lines to a file, and then write some programs that can read them in. These programs should be as general as possible, so you shouldn't know how many records are in the file before you start reading from it. Once you can write and read exactly what you want and without errors, you're ready to move on.